Now another superposition principle numerical. Write down four charges, suppose, are placed four corners of a square. Four charges are placed four corners of a square, four equal charges. Let us call capital Q, and the side of the square is A. Now the question is, what charge we have to place at the center? What charge we have to place at the center such that the entire system will be in equilibrium? Such that the entire system will be in equilibrium. That means the net force on any charge will be zero. Net force on any charge will be zero. So let us find out. Let us first assume that the charge is here Q, small q. So now suppose if you consider this charge, okay, let us find out any one of the charge and what is the net force on this particular charge. Because all of them are symmetrically distributed, so let us take this one. So this charge will experience a force due to this, and due to this. So due to this, these are all plus. So therefore all forces are repulsive. So this plus q will give a force here along the line joining. I said along the line joining. This q and this q also give a force along the line joining downward. So now these two forces actually have the same value. What is the value? F will be equal to K. K means 1 by 4 pi epsilon naught. K Q square by A square. That's the force. K Q square by A square. So what will be the resultant of these two? That will be Fr. So what is the Fr? Fr will be equal to root over of F square plus 2 F square cos 90. Is it not? 2f square cos 90. Cos 90, why cos 90? Because the angle is 90 degree and cos 90 is 0. So therefore this entire thing will be 0. So therefore it will be root over 2f square. So it will be equal to f root 2. And that means it will be equal to kq square by a square root 2. That is the Fr. Okay. Now another force is there, that is due to this plus q. This plus q and this plus q also repel each other along the line joining. Okay. So therefore this is also F dash, suppose, the repulsive force, and that F dash will be k q square by, what is this distance? This is a, this is a. So diagonal of a square is, we know, root 2a. Okay, root 2 into side. So this total distance is root 2a. That means it will be root 2a square. So you can write it as kq square by 2a square. So therefore the net force outward will be equal to this plus this, sum of these two. This plus this outward force. Now this outward force has to be nullified by this q. So obviously this q should be minus. Is it not? Because all of them are plus, so giving repulsive force. So if this all repulsive force has to be nullified by this small q, so this q has to be minus charge. So if this is minus charge, so therefore this q will give attractive force, suppose F double dash. And what is that F double dash? F double dash will be therefore is equal to k q into small q by, what is this distance? This total distance is root 2a. So therefore this will be half of root 2a. So half of root 2a will be root 2a by 2. Root 2a by 2. That means it will be a by root 2. Is it not? This 2 can be written root 2 into root 2. Root 2 cancel out. It will be a by root 2. So this distance will be equal to therefore a by root 2. So therefore this inward force will be kqq by a by root 2 square. So you can write kqq by a square, and root 2 square means 2. That will be going upward. So this is the inward force. So therefore, according to this question, what we can write? We can write at equilibrium. We can write at equilibrium this Fr plus F dash. That means k q square root 2 by a square plus k q square by 2a square should be equal to 2k qq by a square. So therefore what we can write, k a square cancel out, q square taken out, so it will be root 2 plus half, and that will be equal to 2q, q1 q cancel out, so it will be q, it will be 2 root 2 plus 1 by 2, that is 2q, so q will be, this will be 4. So this is the value of q with a minus sign, obviously, because minus, this q has to be minus, otherwise the f double prime cannot be invert. Okay, so this is the answer, that is q will be equal to minus q by 4 to root 2 plus 1.